Hello, and welcome to project number 2 of our Intro to C Programming series. Like last time, hopefully you'll have done the project already, and we'll have a working version of it, and you'll be able to use this video to see where we did things differently. If you haven't done it yet, or if you got stuck, no worries, feel free to follow along. By the end of this video, we will have a fully functioning version of the project, and we will, I'll be explaining my thought process the whole time, so you'll be able to see how I'm doing things in real time. So, what's our goal for this time? Given 3 numbers, print out the greatest of the 3 of them. Specifically, we're going to get 3 integers, so not floating points and not characters or anything else. I've broken this down into a set of 3 steps before we get started here. Step 1 is going to be get the 3 numbers from the user. Step 2 is going to be sort the 3 numbers we are given. And step 3 is going to be output the result to the terminal. So, let's figure out what we're doing here. We already have standard io.h included, and that should be the only include we need for this. Oh, and you'll notice my text editor looks different this time. I've been using Notepad++ and the Windows terminal up until this point. For the next couple of projects, I'm going to use Visual Studio just to mix it up a little bit. Fundamentally speaking, there's not that much of a difference. Visual Studio being an IDE, or integrated development environment, will just do a lot of things for me, like compiling it and running it all at once, just using this green play button up here. Personally, I don't like to use that. I feel like it takes a little bit of control away from me, but it is a perfectly suitable tool for any programmer. Really, it comes down to a matter of personal preference, and that's what I intend to show here. So, let's get started here. So, step 1, seen above. So, first thing we're going to do is we are going to get our 3 numbers. I want to store those 3 numbers all together instead of having them all separate. So I'm going to use an array. Int number, or numbers, let's pluralize that. Have that be an array of 3 of them, and if I can actually hit the correct keys, that would be nice. So now we have a collection of 3 integers. I actually want to initialize these. So let's have them all set to 0. Ah, right, that doesn't work. Okay. And so now this is where all of the data that we get from the user is going to be stored. So now we want to actually get the input from the user. In order to do this kind of all at once, or rather so that I don't have to write all 3 steps of it out individually, I'm going to use a for loop here. So, for int I equals 0, I less than 3, plus I. So let's see, I'm already noticing something. We use just a raw number 3 here and just a raw number 3 here. If we wanted this to be a little extensible so that we could get any number of input numbers, what I could do is I could define const int max or array size equals 3. And then what this would do is I could just plug array size in here and here, and then I would be able to get as many as I want, and all I would have to change is this one number here instead of both of these. I'm not going to do that right now, but that is an option if we wanted to use a larger array. Let's keep going here. So what we have here is a for loop. If you remember how these work, what this is going to do is This is going to run exactly once when we get to this line when the program is running. This is going to be checked every time the loop intends to run. If this evaluates to true, then everything in the loop will run. If this evaluates to false, then it's going to skip the loop and move on to the next line. And finally, this is going to be run at the end of every iteration of the loop. Just to get a good... Oh, that's my phone. Just to get a good idea of what's going on here, here's another way to write that. So let's say we have int I equals 0, while I less than 3. Loop stuff here, plus I. And just to have every detail written out there, this is going to start at 0. 0 is less than 3, so everything will run in here. Then we're going to plus I. So I will be 1 at the end of the first iteration of the loop. 1 is less than 3, so it'll run again. Then I will be 2. 2 is less than 3. Everything will run a third time. And then I will be 3. 3 is not less than 3. 3 is in fact equal to 3. So the fourth time that this gets checked, the loop will be skipped and we'll be done with it. We'll be running the loop exactly 3 times, and that's what we want. Just for the sake of having... just for the sake of taking up less space on the screen, I'm going to be using the for loop syntax up here, but these are functionally identical. So, select all that, delete that, and let's get going here. So, first thing we need to do, prompt the user for input. And the second thing is we need to get input from the keyboard. Or, that's not strictly accurate. Let's get input from standard in. That is more accurate. So, we need to use printf here. This prompt will be pretty familiar from last time. And the reason part of the reason I'm using a loop here at all is so that I can do something clever with the loop variable. You'll notice I'm using %d here, and that means that I'm going to pass printf an argument here, or I'm going to give it another variable to print out. In this case, I'm going to print out I plus 1. And what this will do is I can actually go ahead and run this. Yes, here we go. Can I zoom in here? Yes. And so you'll notice what this is doing. That means I typed it wrong. But what this is doing is this is input number 1, input number 2, input number 3. This will make our output nice and organized. That's what I did wrong. Put the period in the wrong place. So there. Now it should look the way we want it to. Let me run this again. Cool. Everything's good. Now, instead of just printing out that message, we want to actually, get something from the user. So let's do that. We're going to use scanf again. And so now scanf needs to know where to store the value it gets. So let's use that array we declared earlier on line number 18. This time, this is another time when we can use this loop variable I. So what we're going to do is we're going to say store it in the address of numbers element I. And so what this will do is the first time this loop runs, it will prompt the user for input number 1, that's 0 plus 1, and then it will store the value that the user types in numbers element 0, so kind of right here visually. Then the second time it runs, it will ask the user for number 2 and store that in numbers element 1. Remember, arrays start at 0. And then the third time it runs, it'll ask for number 3 and then store that in numbers element 2. And we'll, real quick, just for grins, let's make sure that works. For int I equals 0, I less than 3, plus I, printf number %d, %d, and we'll be giving it I plus 1, numbers sub I. If this is doing what we expect it to, then after we put all our numbers in, this will print then all the numbers back out. This isn't the end goal of the project, but it will be a good way to check that our thoughts are correct. So let me run this real quick. Build errors. What have I done wrong? Scanf function may be unsafe. Ah, right. Okay. So... okay, so this is Visual Studio trying to put a certain coding style on me. It is absolutely correct that scanf is technically not memory safe. Right this moment, I don't actually care, so let's see if I can make this go away. Define CRT secured no warnings. Maybe that will work. Yes, it did. Okay, so that's all it wanted. Please input number 1. Let's have it be 4. Number 2 will be 5. And number 3 will be 999, 999, 9999. Cool, that's about what we expected. Number 4. That's not quite right. What's going on there? Have I done something wrong? Ah, I see what I did wrong. I did I plus I instead of I plus 1. Small mistake. Quick little typo. Let's try this again. Let's see. Let's do 7, 8, and 99. Yes, this is what we expected, so everything is working according to how I said earlier. Good to know. Now we can throw this out and get back to what we were doing earlier. Step 2, sort the input. So we want to know which of the 3 numbers we got is the greatest one. Effectively, what that means is we have to sort them in such a way that the greatest one ends up where we expect it to. And under those circumstances, whatever is in that location is, by definition, the greatest one. This is something I'm going to be doing a couple of times, so instead of doing it in a loop, I'm actually going to break it out into a different function. So let's go up here. Let's say void swap. Int pointer left-hand side, int pointer right-hand side. Need a comma here. And so the way we're going to sort it is pretty easy. If number sub 0 is less than, or no, not less than, greater than numbers sub 1. We're going to swap those two. What this will do is if... let me run through this using... I'll just type out an example, and we'll see how this works. So let's suppose we have the numbers 55, 76, and 88. That's a terrible example because they're already sorted. 88, 55, 76. There we go. So here's what we're going to do. we're going to compare this 88 and this 55. 55, or rather 88 is greater than 55, so we're going to swap them. If I can get things to cooperate. There we go. So this is going to be 55, 88, 76. So now we know that 55 is in the correct spot. We don't necessarily know that 88 is in the correct spot, so let's check again. We're going to compare the 88 and the 76. 76 is less than 88, or rather 88 is greater than 76, so we're going to swap them again. 55, 76, 88, and now they are all sorted. And we know that the greatest number is in the last position. This is what we'll be doing here. So in fact, oh, that was loud. My apologies. My office chair is trying to kill me. Come on. There we go. And cut and paste that there. So now we have a comment that will explain the, this diagram shows the sorting algorithm we'll be using step by step. So, original first swap. If I could type, that'd be really helpful. There we go. And then second swap. And now this will be a kind of visual example. So let's write the code for that here. If numbers element 0 is greater than numbers element 1, we need to swap the two. We can't swap them by passing copies of them, so we couldn't swap them by doing this. This would just send copies of number sub 0 and number sub 1 off to swap, and then nothing would actually change in the array. So we need to send pointers. And now, when we send these two pointers off to swap, up here, swap is going to work on the original data and not copies of the data. We'll actually write the code for swap in just a moment here. But for now, just swap does exactly what it says. It takes whatever is in LHS and puts it in RHS, and whatever was originally in RHS will go into LHS. LHS and RHS are left-hand side and right-hand side, respectively. This is a shorthand I find myself using pretty often for functions that take two arguments like this. And particularly, I use that shorthand when there's no meaningful difference between the left-hand side and the right-hand side. So, for example, these two lines would be functionally identical. Swap at numbers sub 0 at numbers sub 1 is the exact same as swap numbers sub 1 at numbers sub 0. Because I don't have to differentiate them, I can just call them the left-hand side and the right-hand side, and everything makes perfect sense. So, that's our first swap. Then if numbers sub 1 greater than numbers sub 2, we're going to swap those two. There we go. You might have noticed, I have the memory of a goldfish. So, we have our swaps now, but the swap doesn't do anything. It's just a blank function. Let's go ahead and write that function right now. So, how do we want to do this? Well, if we try doing star LHS equals star right-hand side, then we lose whatever was originally in right-hand side. So we need to save that first. So let's say int temp for temporary equals star LHS. If you remember how pointers work, you can declare a pointer by adding a star after the data type, and what this means is this is more or less a reference to an int. It's not actually, it is not the int itself, it refers to where the int is stored in memory. Similarly, if you put the star in front of a variable that's already been declared, or in front of a pointer that's already been declared, then this dereferences the pointer. This turns the pointer back into the actual number, so we can actually get the value here. So, now we have the original value of left-hand side stored. Let's see, this line here moves the value of RHS into the value of LHS. And this line right here, well, I'll comment it after I write it. Star RHS equals temp. And so now we have used the value that we saved earlier. So use saved original value of LHS and move it to RHS. And so now, at the end of this quick little function here, whatever was originally in LHS will now be in RHS, and whatever was originally in RHS will now be in LHS. Easy. Step 2, sort the input. I should move that up here. And so, at the end of these swaps, the greatest number should be in numbers element 2. We can use that in our output message. So, as an output, we're going to printf %d is greater than %d and %d. So now printf is expecting 3 numbers because we use the %d 3 times. And we're going to give it the numbers from the array we have. So, numbers sub 2, numbers sub 0, numbers sub 1. The semicolon is in the wrong place because I forgot how to type again. Get rid of some of these blank lines. Ignored return value from scanf. I don't care, that's not the point of scanf. Cool. So, let me zoom out a little bit. This is what I assume to be a finished version of the project. I will test it real quick, fix anything that needs to be fixed, and I'll upload the final source code to the website. So let's compile this. I'll just use this button up here. This is part of what makes IDEs like Visual Studio so easy. Instead of having to have the command line memorized like I've shown you in the lectures, you could just hit this button. Please input number 1. Let's do 99. Number 2, I'm gonna say 56. And number 3, let's do 67. 99 is greater than 56 and 67. Cool. That seems to be working the way we expect it to. I'm going to test this one more time. This time I'm going to put the numbers in the right order to start with and see if anything happens. So let's do 4, 5, and 6. 6 is greater than 4 and 5. Excellent. Everything seems to be working the way we expect it to. One last run through before we close this off. First thing we do, we declare an array of 3 integers. We get our input by using a for loop. This allows us to both organize our input, make things look a little nicer for the user, and it allows us to get all of our input at once instead of having to write these 2 lines out 3 times. Then, once we've gotten all of our input, we do a small little sort here. We just determine if the numbers are in the right order. So if the first number is greater than the second number, then they're in the wrong order. We swap them. If the second number and the third number are in the wrong order, we swap them. Easy as that. Finally, we output which of the numbers is greatest and return 0, exiting the program cleanly. Cool. Looks like we've gotten everything done here. Feel free to tinker with this source code yourself, and hope you had fun.